Okay, so we're going to start this video with the rule of 70 for doubling time. Now, this works if you are dealing with compounding annually. So the problem has to be compounded annually, and if that's the case, we can figure out how long it will take for the money to double. And it doesn't matter how much you start with. You can start with $20, you can start with $20,000. It would take the same amount of time for that money to double if you are compounding annually. So this here box on page 188 is the basic premise for doubling time. You will take 70 divided by 100 times the rate, and that gives the number of years. So you can see a little bit underneath here, pointing to this spot now on page 188. If you have an APR of 3.5%, look at the problem. 70 over 100 times the rate as a decimal, so two places to the left, and then you multiply. Now this is the thing that gets me, okay? And I want to point it out to you just so that you're not confused. If you change 3.5 to a percent, you get 0.035, just like they did here in this problem. But when you do order of operations, you've got to multiply in your denominator first, which leads you back to 3.5. So the rule for doubling is kind of the same as taking 70 divided by your rate as a percent. And that's the key, because usually when we see R is a decimal. When you see R, because usually we're playing with it, and remember, when you're playing with math, you have to have decimals. We don't play with percents, we play with decimals. So I just wanted to point that out so you're not saying, that doesn't make any sense. Well, yeah, it should. Okay, so we'll do a couple examples here where you can see how this works. Okay, so in that first example, let me even show you, come back, the one that we talked about down here, we said if we have an APR of 3.5%, it will take 20 years for it to double. So in this example, we said, okay, we have $5,000, and here we have the 3.5% we just talked about. How much will we have after 20 years? So let's use our balance equals principal times 1 plus 0.035 raised to the 20th power. Now remember, we're compounding annually. That's once a year, so we don't have to divide by anything, because if you divide by 1, you're not changing anything. So when I plug that into my calculator, my ending balance is $9,948.94. So did our money approximately double? Because when we took 70 divided by 3.5, we got 20 years. So when we looked at it, well, how much would we have after 20 years? Did it nearly double? Well, yeah. I mean, $9,948, that's close to $10,000. You know, we're $51.06 away, but we're still fairly close. So that's kind of how it works. Now, I would like you, if you feel comfortable, to try number 2, just number 2, A, B, and C, and then come back and I'm going to go through and explain all 3 parts. But I just want to see if this makes sense to you, if you can answer any of these. Okay, so let's try number 2. Okay, and number 2, using the rule of 70. So remember, the rule of 70 gives us 70 divided by 100 times R. So I would take 70 divided by 100. Our rate is 7%, which is 0.07. So that's 70 divided by 7. And we end up with approximately 10 years as our doubling time. So if this should double in 10 years, let's go to part B and say, okay, that means 5,000 times 1 plus my rate of 0.07 after 10 years should be doubling. Please excuse me there. So when I plug that into my calculator and I do the math, order of operations, I end up with $9,835.76. Now, did the rule of 70 work, right? Did it give a good approximation for the doubling time? Well, is my answer. I mean, 98.35, that is close to 10,000. But you know, if you owed somebody $10,000 and you try to give them 98.3576, I think they're going to break your kneecaps. So I guess it depends what you're doing with this $10,000. If you're just saying, you know what, I really would like a down payment on a car, I want to get close to $10,000, how long would it take me to get there? You know, then in that case, yeah, this is a great example. So it really depends, I think, on what you want that $10,000 for. So, okay, go ahead. Example 3 talks about population. Now, whether we're talking about money or we're talking about population, the rule of 70 works because we're checking out at once at a time. So let's go ahead and would you please try to find number 3 and then come back and check those out. All right, so Liberia has a population growth rate of 4.5%. So if we think about the rule of 70, remember, it doesn't matter what the population starts with. It's all about the growth rate. So 70 divided by 100 times 0.045 gives me 70 divided by 4.5. Liberia's population, I rounded to 2 decimal places, will double in 15.56 years. So in our lifetime, if this was the case, the population would double, in the next 16 years, which I think is crazy. Now, depending on what the population is, maybe the population right now is 20. In that case, it wouldn't be bad. But for a country that has a population of, 2 million, doubling that in 16 years, going from 2 million to 4 million, could be really out of control. So, and of course, population can be growing for a number of reasons. Obviously people are having babies, but you could also think about people could be moving into the area, right? That increases the population of a specific area. So there's all kinds of things that could be going on here. So, okay, let's go ahead and look at part B, which is Spain. Now, 0.007, if I move that 2 places to the left, right, this is 0.0007 as a decimal. So when I go to do my 70 divided by 100 times 0.0007 gives me 70 over 0.07, which comes up to be 1,000 years. So because Spain has a population that is growing so much slower than Liberia in this case, so Liberia is going to double their population in 16 years. Spain is going to double their population in 1,000 years. So that's a bit of a difference. So you can see how a difference of 4.43%, sorry, it's a little slow here to do math on a Sunday, a difference of 4.43% causes a difference, in 985 years in terms of doubling time. So that's kind of intense. So just doubling. So let's do a Becky special, just one problem here, and say, let's say you have some money and you are investing it at a percent of 2.2%. How long will it take to double? So this is just an extra problem for fun to think about. So always remember it's 70. And if I want to do it the easy way, I would do that 70 divided by 2.2. And if that's the case, it would take me 31.82 years to double. But remember, this is only if you are compounding annually. Anything besides annually will not work with this model. So please make sure to keep that in mind. So that's the basics of the doubling function, rule of 70. So thanks for watching and have a good day.